Hi everyone, I hope you're all doing well. So in today's video, I'm actually going to go smash through the 2017 Specialist Maths exam paper for exam 2 for the Northern Hemisphere, extended response. Like always guys, before I start this video, if you guys want private tutoring in Specialist Maths, mathematical methods, physics or chemistry, you can always email me through this email. Guys, we have great news. We just have launched our website, and this website pretty much has notes if you guys want, specialist notes, physics notes, chemistry, physics. Currently, we just have physics right now, but in the future, hopefully, we do post some of the specialist methods, physics, and some chemistry notes. If you guys, want those notes, you can always, purchase them there. They are very cheap. They are $10 a note, and believe me, they are very comprehensive. They help you a lot. We are also actually going to start, posting some practice exams, and these practice exams are going to be very similar to the VCA. If you guys want some practice exams, you can also purchase them through there. And yeah, let's actually smash through this video. Let's go. Question 1. Use an appropriate double angle formula with t equals this, so t equals tan phi over 12, to deduce a quadratic equation of the form t squared plus bt plus c equals 0, where b and c are real values. Okay, so we need to use a double angle formula. I know that the double angle formula for tan is going just to be 2 tan of x. This is in your formula sheet, guys, if you don't know. It's just 1 minus tan of x squared. So what can we do? Well, we want to make a quadratic that looks like this. I know that, okay, if t is equal to tan phi pi over 12 and this is being squared, and also this variable is being squared. Okay, so what I can do is imagine that, if tan of x is, tan phi pi over 12, then tan 2x is just going to be tan 5 pi over 6 over 2 tan 5 pi on 12 over 1 minus tan 5 pi over 12 all squared. Now, we know that t is equal to tan 5 pi over 12. So, okay, let me actually simplify this. So, tan 5 pi over 12, if I'm not mistaken, it is negative 1 over root 3 is equal to 2. We know that tan 5 pi over 12 is just t, so t. We just substitute 2 of those. 1 minus t squared. So, let's simplify that. So we get negative 1 over root 3. 1 minus t squared is equal to 2t. So negative 1 over root 3 plus t squared over root 3 is equal to 2t. So if I multiply everything by root 3, we get negative 1 plus t squared 2 root 3t. And hence t squared minus 2 root 3t minus 1 equals 0. So yeah, that is the quadratic. Is it in that form? T squared, where b and c are real numbers. That's good. That's pretty much it. So let's highlight that nicely. Okay, next question. Hence show that tan 5 pi over 12 equals this. Okay, because it says hence, so we have to use this previous question to help us. So if I know that tan 5 pi over 12 is just t, don't we just solve this? Don't we just solve this equation? So let's solve it. It's a quadratic, so I'm just going to use the quadratic formula. So I know for a fact it's going to be t is equal to negative b, which is just 2 root 3, plus or negative b squared, which is 4 times 3. So 4 times 3 is root 12 in here, and then squaring it because it's b squared, it's going to be 12 minus 4, a is 1, c is negative 1 over 2a, which is just 2. And simplifying this much further, so 2 root 3 plus or negative, that'll just become 4 over 2, which is root 3 plus or negative 2. So we get 2 values, but we can see that this is positive, and we have to also explain why we take the positive value. Let's think about it. Okay, if I was going to sketch kind of this over here. If I was sketching this and 5 pi over 12, what is it? It's around 75 degrees if I'm not mistaken. So if I was drawing 5 pi over 12, it's right over here. Just over here. And what do we see? If I break it down into its components, and remember, just imagine dividing this by 1. This is your opposite and this is your adjacent. Yes? And what do we know? Well, here, this will be, imagine this is our theta, this is our opposite, and this is our adjacent. So, what do we know about our opposite and adjacent? They must be both positive. If they're going to be, 75 degrees over here, 5 pi over 12. This over here and this over here must be positive. So, for a fact that this over here is just 2 plus root 3, our opposite, and here is just 1, both of them must be positive. So, that's why, we only take the positive answer. So, t must equal to pretty much 2 plus root 3. That's it. Alright, I hope everyone understood that. So yeah, just that kind of... Okay, let's go to question this. B, if f is between root 3 this, or real f of x is equal to this, sketch the graph of f on the axis below, labeling the endpoints with their coordinates. Alright, that's easy. So we'll just have to sketch it. What I'm going to do is just go on menu, go on actually graph and say, we want to sketch arc tan of x over 3 minus pi over 6 from root 3 root x root 3 6 plus 3 root 3 and press enter, and this is what the graph looks. I want to make sure it looks similar to what the exam paper looks, so I'm just going to go on Windows and Windows settings, and I'm going to say x minimum is going to be negative 12. Here's going to be 12. X scale will be, they go by 1, so 1. Your y min is going to be negative 0.5. Your y max is going to be 1, and they go by 0.1. Enter, and we get this. So go menu, go to view, go grid, and go to lined grid. Perfect. So again, just copy this exactly on your paper, and let's do that. So we can see that if I just zoom in, I know for a fact that this is going to be point over here, point that passes through here, point that passes through here, here. And I'm just going to make my life easy, actually, just go on, I want to go to trace, and what's at 5? If I press 5, x equals 5, it's just 0.5. So at 5, it's approximately over here. What about 10? It's 0.75. So imagine that 0, 6, 7, 0.5 is approximately over here. But I want to be careful because I want to make sure it's still in that domain. So what the endpoint... What's the endpoint for? Okay, let me just say, what's f1 of, what's the endpoint? So one of the endpoints is root 3. Okay, makes sense, 0. What about the other one? So it's 3, 6 plus. It's pi over 4, which is approximately 0.785. So 0.785 is approximately, and wait, what's the actual number of this? It's 11. Okay, so around 11.1. So 11.1. So 11.1 is over here, and approximately it's 0. It's approximately over here. So yeah, it's 0.67. Yes. So now, just sketching this nicely, putting this all together, we get this. And that's it. So now we just label our endpoint. So this endpoint over here is going to be root 3, 0. This point over here is going to be 6 plus 3 root 3 pi over 4. Done. So with the exact, it says, And yeah, that's pretty much it. Nice and easy. Question C. The region between the graph of f, so the region between the graph of f and the y-axis is rotated about the y-axis to form a solid revolution. Write it down a definite integral in terms of y that gives the volume of the solid revolution. So what's happening is that, imagine this, let me just do a rough sketch. It's just being rotated around this y-axis, and that's what we want. We want that volume. And this is how you would write the definite integral. This is so we write volume is equal to pi, the integral. Because it's rotated around the y-axis, we want to write dy. And so it means that these values here must be y values. So we're rotating it around from 0 to pi over 4. So, okay, that's good. So 0, pi over 4. And because this is y, imagine that the inside it has to be x squared. So what's x squared? We need to calculate what's that x squared. Well, if I know that y is equal to pretty much tangent inverse of x over 3 minus pi on 6. We just want to solve for x, and we want to square it. So it'll be y plus pi on 6 tan of this is equal to x over 3. Hence, 3 tan y plus pi on 6 is equal to x. And imagine squaring it, so because we want x squared, so it'll be 9 tan squared y plus pi on 6. That's x squared. And yeah, now let's put that in to our equation. So this 9 tan squared y plus pi on 6. That's it. And pretty much that's your answer. So I'm just going to make this little. And yeah, I want to write it nicely actually. Y plus pi on 6. Yeah, dy. So that's your final answer. Alright. I want to see if there's a bigger. Yeah, okay. Find the volume of the solid correct to the nearest integer. Very easy. Just rewrite this whole expression and calculate it on your calculator. So we're saying that pi times the integral from 0 pi over 4 9 tan y plus pi over 6, this whole thing, and then we're all squaring it, dy. Control enter. So to the nearest integer, it's 67. Let's write that down. So pretty much 67 units cubed. That's your answer for that one. Nice and easy. Question D. I want to use a different color now. Let's use this color. So a fish pond that has a shape approximately like that of the solid revolution in part C is being filled with water. When the depth of is h, the volume v meters to the power 3 of water is given by this. If the water is flowing into the pond at a rate of this per minute, find the rate at which the depth is increasing when the depth is 0.6 meters. Give your answer in meters per minute to 3 decimal places. So, okay, the volume that we calculated looked like this, if I'm not mistaken. It looks like a vase, and they're shoving some water inside there. And, okay, and we want to calculate the water is flowing at this. So if the water is flowing at a rate of this over here is dv dt, because it says this is in volume per minute, which is in time. It's actually just 0.03. It is positive because it's flowing into the water, so we have that, and we want to find a rate at which the depth, so depth is in this case h, so we want to find dh is equal when the depth is this, and give your answers in meters. Yep, so meters per minute. So dh dt We want to find dh dt given that h is 0.6, and that's what we want to calculate. Okay, so what is dh dt? Let's think about it. dh, let me write it nicely actually. dh dt can be written as like dv, actually no, just dh times dv times dv dt. Why did I write it like this? Because I'm writing these dv's over here, so when they get multiplied, I can cancel them out. It's just dh over dt, which is equal to this. And because I already know that dv dt is 0.03, so I already know this one, I just need to find dh dv. And how do I find that? We use this over here. So, you know, imagine like deriving this. We get dv dh. So if we derive that using our calculator to do that, so with the respect of h of tan h plus pi over 6 minus h minus root 3 over 3, we get this. So let's write that down. So that can be written as tan h plus pi over 6, pretty much all squared. Now we got this, and what we want to do is we want to reciprocate it. So dh dv is just the reciprocal, which is just, you can write it as just tan h plus pi on 6 to the negative 2. And yeah, now let's multiply them together. So dh dt is this expression right over here. Let's copy that. I want to take this and just make them kind of smaller. Put them over here. So I want to take this expression over here and multiply it with 0.03. Now this over here is dh dt. So now after that, I just want to find dh dt given that h is 0.6. I want to find that. Now that's going to be easy, so let's do that in a calculator. So this over here, imagine finding the reciprocal. Oops, just put a negative over here. That's a reciprocal now. So we have this, and we're going to multiply it by 0.03, and we get this beautiful expression. Now we're just going to find when h is equal to 0.6. And that gives us control enter this value. So we want to correct to 3 decimal places. So let me write this nicely. 0.6, 0.007. Is that right? To 3 decimal places and in meters per minute. So meters per min. That's it. Yeah, so that's not too bad. Let's take this, make this much smaller. Right over here. That is your answer. Good. Question 3. One root of a quadratic equation with real coefficient. Okay, when you hear the word real coefficient, what do we know? Conjugate root theorem is this. So this here is a root. Write down the other root of the quadratic equation. So, okay, by converse conjugate root theorem, we know that if we have a root, for example, this one, we have root 3 plus I. By conjugate root theorem, the conjugate of z is, which in this case is root 3 minus I, is going to also be a solution, a root of the equation. So yeah, so hence your other root is just going to be this one over here. So we have those two. Hence determine the quadratic equation, writing it down in this form. Okay, let's think. That's pretty much it. That's very easy. So this is the way, have you ever understood that this is actually a form that a lot of students don't know, but the form of a quadratic is if you have 2 roots, so z squared minus alpha plus beta z plus alpha beta equals 0. Now you're probably like, what the hell is this? This is kind of a, if this is what it means, pretty much. If you have two roots, well, in this case we do. We have alpha, in our case, is root 3 plus I, and your beta is root 3 minus I. This is just a form of writing it as quickly as this into this form. So you know how you can normally expand it? So like, you know, you can write it as a factor form. So it's z, you know, minus root 3 minus I, z minus root 3 plus I. Like it's, yeah, you can do that. But whereas to this method over here, what we can do is just write it in this form. So z squared minus, what's alpha plus beta? If we add them together, it's just 2 root 3. And that's z. Then the next one is just alpha and beta multiplied together. Because they are perfect differences of perfect square, it's just going to be 3 minus I squared, which is minus 1, which is in this case plus 4 equals 0. We just did it in a second without even, you know, kind of factorizing or, you know, doing all that work. Yeah, so that's it. That in that form. That's easy. Let's do that. Plot and label the roots of z to the power through this on the arcgram diagram. Okay, so because there's a common factor of z, let me just take that z out. So that'll be z squared minus 2 root 3 z plus 4 equals 0. And this looks the same as our equation over here. So, but we also have one more root, which z equals 0. And the other roots are still 2. So let's actually plot them. So if I was plotting those, so z equals 0, it's going to be 1. So inside, well, that's not a good color. If I just put it, well, actually, that's also not a good color. What color can I use that's very, this is yellow. So we have 1 here. So z, which is 0 plus 0i. Let me write it down. Yep, so that's one of them. And we also have the other two roots, which is root 3 plus I, so that's going to have a radius of 2. So it's over here. One's going to be here, and the other one's conjugate of it, so it's going to be over here. So yeah, so this over here is going to be z is equal to root 3 plus I. This one's z root 3 minus I, and this one over here is going to be just z 0 plus 0i. We have labeled them. Plot and label the roots. That's it. C. Find the equation of the line that is perpendicular bisector of the line segment joining the origin and the point. This, express your answer in this. Now, you might be confused what the hell they're saying. Okay, let's read the question very slowly. It's saying find the equation, so we need to find the equation of a line, okay, that is perpendicular bisector of the line segment joining the origin and the point. Now, okay, let's think about it. Line segment joining the origin and the point this. So, okay, so we origin and this point. What are those? So it's this point over here and this point over here. Yes? And a line segment is pretty much a line that goes towards them. So it's a line that connects them. It's a segment. So, okay, that's easy. So we just did the line segment joining the origin and this point. And we want to find the equation of the line that is perpendicular bisector. So imagine that a perpendicular line that is right angle to that line and it passes through the midpoint. That is what a perpendicular bisector is. So having to draw on that, okay, and we need to find the equation of that line. So how do we do that? Well, let's think. If I can make these points, now this point here is just root 3, 1, whereas this point EV is just the origin, which is 0, 0. If I can find the gradient of this, and I can find the gradient of the normal to find the gradient of this, I can also find the midpoint because I know these two over here. Using the midpoint formula, I can find those midpoints. So let's do that. So what I'm thinking is first, let's find the gradient. So the gradient of just the line itself, this line over here, this line, is just going to be 1 minus 0, I think. Yeah, so it's just 1 minus 0 and... So 1 minus 0 and root 3 minus 0, which is just 1 over root 3, and it's positive, yes. And let's find the perpendicular gradient, which is just negative root 3 pretty much. It's just negative 1 over that gradient. And now we have the gradient of this line. Now let's calculate the midpoint. The midpoint is just taking those two coordinates and adding them and dividing them by 2. So the x-coordinate and the y-coordinates. So for x-coordinate midpoint, so the mid of the x-coordinates is what? Adding both the coordinates, so root 3 plus 0 and dividing by 2. That's root 3 over 2. Your y-coordinates for the midpoint is just adding, so 1 plus 0 divided by 2 is a half. So now we have the coordinates. Now just use the equation of a line, which is, y minus half equals negative root 3 x minus root 3 over 2. And y should equal what? So I'm just going to use my calculator to be short. So y minus 0.5 equals negative root 3 x minus root 3 over 2. And yeah, so then I want to solve answer comma y. And this is your equation. Let's write that down. We can write that as negative root 3x plus 2. Done. In that form, that's it. Next question. The three roots plotted in part B lie on a circle. Find the equation of the circle expressing your answer in this. So, all right. I mean, this is so confusing. Let me just pretty much rub a lot of these out. Okay, let's rub these out. Let's draw that root back here. Okay. Let me rub this out. Pretty much rub this out. Okay. So these over here, they lie into a circle. Let me just draw a rough rubbish circle. Like, they lie on this circle that looks like pretty much like this. That's not the best circle, but imagine it looks like this. Now, I don't even know how to find the circle, so I'm just going to think of a basic, easy way. I know 3 points. Think about it. I know 3 coordinates, pretty much. Yes, so I know the coordinate is 0, 0. It passes through 0, 0, and it passes through this one, which is just root 3, 1, and root 3, negative 1. I know it passes through this. So what I'm going to just do, make my life easier, and is... Okay, first let's understand this notation, actually. The beta here is actually your radius. This is in your complex, like... this is how they can write it in complex, in the terms of like the complex, and pretty much this is a circle, and this over here is your radius. This over here is your coordinates. For example, if you had z minus 2 plus 3i, it means the middle point is going to be 2 minus 3. So this here just becomes 2, this one minus 3. That is your middle point of the circle. So in this case, we don't actually have that I, so we just have alpha, meaning that, and we know that they are real, so it means we pretty much our y value for our middle point of the circle is just 0, and it makes pretty much sense. I mean, so it should lie around here, pretty much. If I was drawing it, it would lie around here. So we don't have any y value, so that's good to know. And yeah, so knowing that, and I know 3 points. What is an equation of a circle? Like, what is the form? I know I'm just going to make my life easier and say, I know it's going to be like x minus a, which I don't know what a is, squared, plus y minus b squared equals c squared, where c is pretty much, the c value is our radius. So, okay. And I also know 3 points. So I know that we know the point 0, 0. So let's put that 0. So at point 0, 0, we're saying that a squared, and if we put 0 on y, so it'll be b squared equals c squared. Wow, this is just, okay, that's one of the equations. And the coordinate, what's the other coordinates? Root 3, 1. So root 3, 1. Let me just zoom it out. Yeah, and that gives us root 3 minus a squared plus 1 minus b squared equals c squared. That's your second equation. Your other equation is this, the third equation, sorry. So it's root 3 minus a squared plus negative 1 minus b squared c squared. That's your third equation. And use your calculator. Let's use our calculator and find those values. So go on menu, go into algebra, solve systems of equations. And we have 3 equations, and our terms, we want to find a, b, and c. Okay, and let's write those. So the first equation is pretty much just a squared plus b squared. So a squared plus b squared equals c squared. The next one is root 3 minus a squared plus 1 minus b squared equals c squared. And that one's similar to the second equation, but it just has a negative over here. Enter, and we get pretty much these values over here. Now, of course, b is 0, because that's where we don't have a y center. So it could be this one, or it could be this one. Now, of course, it's not going to be this one. We're saying that the radius is negative. This is rubbish. C is our radius, and it's saying that C is negative, so it can only be this one over here. So let's take these over here, these values. So we'll write this as x minus 2 root 3 over 3. Well, that's not a nice bracket, so let me just... And so if that's 0, so it'll be just plus y squared equals 2 root 3 over 3 squared. That's easy now. We can write it in that form because we have everything. So what's our alpha? Alpha is going to be this over here. So our alpha is going to be 2. Let me write it now, actually, here. Alpha is just going to be 2 root 3 over 3. And your beta is just going to be your radius, which is just 2 root 3 over 3. Same thing. That's great. That's it. Those are your answers. So find the equation expressing it in the form of this. So we know those two values. Oh, I need to express it in that form, sorry. So hence your final answer is z minus 2 root 3 over 3 is equal to 2 root 3 over 3. That's your answer. Great. Question 3. Bacteria are spreading over a petri dish at a rate modeled by this differential equation. dp this, okay, where p is between 0 to 1. Okay. Where p is the proportion of the dish covered after t hours, express to this in the partial fraction form. Okay, it's just like they've just kind of inversed that. So that's easy, just using your calculator. I'm just going to control n everything here. I don't need this anymore. Okay, so what we want to do is partial fraction. So I'm just going to go and expand to do this. 2p times 1 minus p, enter, and this is the partial fraction form. So let's write that down. So this can be written as 2 over p plus 2 over 1 minus p. So what I did was just that negative I didn't like, so I just, because I want to write it in that form, just took that negative and cancelled that. So that can be expressed as this. So that's it. Express your answer in the partial form. That's it. Partial fractions. Hence, show by integration that this t minus c, this, where c is a constant of integration. So we want to show this and that. Okay. So imagine that this over here, we want to, like, if we flipped it, it would be dt over dp. Yes, which is going to be 2 over p 1 minus p, which is actually equal to the partial fraction form what we just did. Okay, and yeah, so if we integrate that, we get t is equal to the integral of 2 over p plus 2 over 1 minus p dp, which is t equals 2 log e. We don't need absolute value because we know that p is between 0 to 1. So p minus 2 log e 1 minus p. Again, 1 minus, because p is between 0 to 1, we always get the inside the log is always greater than 0. So that's good. Okay, and we're going to plus c here. All right, so we want to get in that form. So if we say t minus c, bring that t, and we take a common factor of 2 out of both of them, we get log e p minus log, minus log E 1 minus P, we get, just kind of simplifying this further, oops. Nicely here. We get T minus C over 2 equals, these log by log laws is just log E P over 1 minus P. That's it. And that looks similar to what we want to show. That's it. Good. So if half of the petri dish is covered by bacteria at T equals 0, express P in terms of T. So we just want to calculate the value of constant and then solve for P. Because, you know, P is between 0 to 1. When they're saying half, it means that when P is half, when T is equal to 0, this is our initial condition. So let's write that down. So using this equation over here, using that equation right over there, let's put those values in. So it's going to be 0 minus C over 2 log E half. 1 minus half is just half, which is just 1, which becomes log E. This whole thing becomes 0 pretty much. Hence C is just 0. So write this whole equation. It's just 2 over 2 log E P 1 minus P. And we solve for P. So it'll be E T over 2 P 1 minus P. E T over 2 minus P E T over 2 equals P. So hence T over 2 P 1 plus E T over 2, that. Hence P is just going to be E T over 2 1 plus E T over 2. That's it. That's in terms of P. That's it. Nice and easy. That's not too bad. Next question. After 1 hour, a toxin is added to the petri dish, which harms the bacteria and reduces their rate of growth. The differential equation that models the rate of growth is now this. Okay, so this is still normal, but then we're going to minus this rate of growth of the bacteria. Okay, still good. With T is greater or equal to 1. Find the limiting value of P, which is just the maximum, which is the maximum possible proportion of the petri dish that can be covered by bacteria. Give you an answer to this. So the limiting value of P is just the maximum possible proportion. And that's easy because we can calculate it because we have dP on T. We just want to let it equal to 0. So dP dt equals 0, meaning that P over 2, 1 minus P minus, this 20 must equal 0. So let's do that in our calculator. So P over 2, 1 minus P minus root P 20 equals 0. And we want to solve answer, comma, P. Control Enter. So we get P equals 0 and all these values. Now, okay, P equals 0 is impossible because remember we said that P is only between 0 to 1. So that's rubbish. P is between this and, okay, this here is the smallest value. So this most likely is the minimum, but we want the maximum possible. So this is your maximum possible. Let's write that down to 3 decimal places. So P is 0.3 decimal places, so 0.894. That's it. Okay, next question. The total time T hours measured from time T equals 0 needed for the bacteria to cover 80% of the petri dish is given by this, where Q, R, and S are real numbers. Find the value of Q, R, S given the value of Q corrected 2 decimal places. So what have I done here? Okay. So if they reciprocated this to get it in terms of dt dp, and they found the integral of it. Okay, I need to tell you something in this form. It's in the actual Cambridge. So, for example, if you had, let's say, y equals x. Actually, Yeah, something like y equals x. And we want to find the integral of this. So we normally will integrate it. So we'll integrate x. So we'll integrate x respect of dx. Okay. And then, we're going to have plus c, a constant, and we're going to solve for c using our initial condition. There's actually a faster way you could do this. And what is this way? Well, this is how you do it. What you put in here, the bottom terminal, is your initial condition x value. And you're going to add your y condition. For example, your initial condition and your y initial condition over there. And over here, we normally put x, meaning where we want. Normally, we put x like to get it in terms of x. But here, our x value actually just means where do we want to go to. So using this kind of form, it's saying the total time measured from t equals 0 needed for the bracket to cover 80%. So we want to cover 80%, okay? And remember here, it's in terms of p. So our value here, our q here means what? It's our p initial. Our s here is going to be our t initial. And over here, r is where we want to go to, which in this case is just 0.8. So our r value is just 0.8. That's easy. 0.8. That was not too bad. But what about the other values? So q, s. So we need to find some initial conditions actually to do that question. So what can we do? Well, okay, we did get this, but can we calculate the value? We need the time. No, we can't calculate the time because then, yeah. Okay, what do we do? Well, remember, guys, that after t is greater or equal to 1, so think about it like this. So this is when, this condition over here is when it was just pretty much, what is this? So convergence differential equation. Okay, so this is where, this is just by itself, the bacteria is growing, this equation. And what's happened is, after 1 hour, they've put this over here, which now reduces that bacteria. So think about it like this. What do I mean, pretty much? So if I was drawing, for example, let's call this over here when there was just bacteria itself. Let's call this graph over here bacteria itself, and it passes through this point over here. And this here, it's the time. So imagine this whole graph. Remember, so at t equals 1. Because remember that what he does is he uses this equation over here to get the time from 0 to 1 hour. So from 0 to 1 hour, where just the bacteria is growing. But then after 1 hour, what happens is it reduces the growth rate by he puts something else like this over here, and now, for example, the line will go down like this. Let's call it goes down like this. But can you see that they would have been continuous? They were normally continuous at this position at t equals 0. At t equals 1. So remember, this over here is your p-value. So both equations, like for this one, this is what we don't have the solution for. Whereas this one, we actually have the equation over here. And if I'm not mistaken, I can just... so what's the t equals, like when t equals 1, we can find that p-value. And that's an actual initial conditions for us. So that's good to know. So what I'm going to do is I'm going to go with my calculator and say, okay, write that equation. So E, which is 0.5 actually. 1 over, yeah. 1 plus E 0.5. So again. Enter, and we get 0.6 this. So that is our P naught. So we just got our Q value. Your Q value is what? To 2 decimal places, that's 0.62 to the decimal, yeah. And what is our so RQ and SR value? What's our T naught? Our T naught is 1. Remember, we are putting 1 when T is equal to 1. Yeah, those are your values. Given that P is equal to this when T equals 3, use Euler's method with a step size of 0.5 to estimate the value of P when T equals 3.5. Give your answer correct to 3 decimal places. That's not too bad. So let's call this P naught 0.75 and T naught is 3. And we want to calculate, so we know that T1 is just the step size plus the T. So T0 plus the step size, which is 0.5. So 0.5 plus 3 is just 3.5. So we just need to calculate Y1, which is P1. P1, using a formula, like it's in the Euler's formula is actually used in the, it's in your formula sheet. It's just P0 plus your step size. Normally it's F, but in this case it's like dP, your actual derivative. So like, how would you even write that? Would you just call it P dash? So like, in this case would be like, yeah. So I don't know, I would say P dash is x0, which in this case is 3. So this is our P dash over here, dP dt. This is our P dash. So what we just can rewrite this is, okay, P1, let's write the whole equation. So P1 is what? P0 is 0.75 plus H is just 0.5. And P dash of 3 is just like subbing 3 into this. Let's do that. So 3 over 2, so we're saying that what's 3 over 2? 1 minus 3, so 1 minus 3 minus root 3 over 20. And that's it. So we're running this whole thing. And we get P1. Let's do that. So 0.75 plus 0.5. 3 over 2, so 3 over 2 negative 2 minus, oops, minus root 3 over 20. What have I done here? Have I done anything wrong? Have I actually done something wrong here? Did I mess up something? 3. Well, I think I've just written the algebra wrong. So wait, let me just write the P here. Let's just write the equation. So P 2 1 minus P minus P over 20. So we got this equation, and what we're saying is when P, what's our P value? Oh no, it's when P equals 0.75. That's our equation. What am I doing? Wow. Wow. So imagine, like, yeah, so forget about that and just say like, when here, it's supposed to be 0.75. Here, inside here, it must be 0.7, like P dash. P dash 0.75. Just using this in your calculator. So if P is 0.75, oh, I'll double sign test that. We get this part over here, and so and we multiply it by the step size, and then we add it with our 0.75. We get this. That's good. So correct 3 decimal places. That's 0.775. Wow. Oh, that was a stupid mistake. Yeah, because it was in terms of P. I thought it was in terms of T. So don't make that mistake. So that'll be it. Question 4. A cricketer hits a ball at time t equals 0 seconds from the origin at ground level across a level playing field. The position vector r of t from O of the ball after t seconds is given by this. This is our vector, where I is the unit vector in forward direction and j is in the vertical up direction. Displacement occurrence are measured in meters. Find the initial velocity of the ball and the initial angle in degrees of this trajectory to the horizontal. So I think this is just projectile motion pretty much. So imagine this cricket, he hits this ball, and like he hits it with some velocity, initial velocity. And let's say this is velocity, and what happens is the ball goes through projectile motion and goes down, touches the floor again. So, okay. If we know that r, we want to find the initial velocity, the initial. So, if we find r dot of t, let's find that. So, it's just, what I'm going to do is just, so I'm going to define r of t, position vector, as 15t, 15 root 3 t minus 4.9 t squared. Just want to make sure everything looks good. 15t, 15 root 3t, make sure you always, okay, that's it. So I want to derive it, so with the respect of t. And that gives me this, so let's write that. It'll be 15i plus 15 root 3 minus 49 over 5tj. And we want to find the initial, so when r of t is actually 0. Let's do that. Imagine taking this vector over here and letting t equals 0. And that's your actual initial velocity. So it's 15i plus 15 root 3j. That's it. That's your initial velocity, and we also want to find the initial angle. Okay, think about it. So if this is your initial velocity, if we break down this component, because this is over here, break this down to components. If I know that this velocity vector was the, this is the angle we want from the horizontal, okay, we want this angle, and if we break down this velocity, as an example, this velocity, the horizontal velocity is 15 from this question, so that's 15 over here, and 15 root 3. So to find this theta over here, it's just going to be, so theta is just going to be the tan inverse of pretty much root 3, because 15 root 3 divided by 15 is just root 3, which is, in this case, pi on 3. Am I making him say it? Wait, so opposite, I want to be sure, yeah. So, of root 3 is pi on 3, great. So it's pi on 3, so that's pi on 3, and we want it in degrees, so that's 60 degrees. Okay, and we want to write theta 60 degrees. That's it. Not too bad. Find the maximum height reached by the ball, giving your answer correct to this. So, okay, think about it like this. This maximum height over here, which is over here, you should know a property that when we reach the maximum height, the actual vertical velocity becomes 0. So the vertical velocity becomes 0. So if I know r of t is 15i plus 15 root 3 minus 49 over 5 t j, we know that the vertical velocity becomes 0. So imagine this over here, we let it equal to 0. That's your vertical velocity. And we solve for t. So we get t is equal to what? So I'm going to do this quickly in my CAS. So I know that this over here, take this over here, equals 0. And I want to solve, answer comma t. And we get t equals this, so let's write that down, 2.65. And now going back to our position, so r just t, and putting this number here, 2.65, this results, let me just put it over here, this results in, what's r of this number over here. Control enter, and we get these numbers. So 39.76i plus 34.438j. Now, because we want the maximum height, we want the vertical. So our only answer would be height. So height, maximum height into 2 decimal places will be 34. We want this one over here. So that's your vertical, 34.44 meters. Yeah, corrected the decimal places. That's it. Next question. Find the time of the flight of the ball. Give your answer in seconds. Okay, so if we know the time, by the way, this is an extra. So if I know the time over here, which we've already calculated, is 2.65. Remember the symmetry of a parabola. Wouldn't it be just this over here, this time, we know it's 2.65. It should be the same over here until it hits the ball, which is another 2.65. Hence, it's in other words, double the time. Yeah, so most of the physics students would know this because, you know, if you do projectile motion, pretty much, yeah. So if I know that the time it takes is just going to be 2 times 2.65. So hence t is equal what? To correct to 3 decimal places, so it'll be 2 times this over here, which gives us 5.3 to 3 decimal places, 0.2 seconds. That's it. Find the range of the ball in meters, correct to 1 decimal place. So we want this range, the distance from here to here. If we know the time, we just can put it in our distance. So r of 5.3, let's call it 5.3, gives us what? Because it's only 1 mark, let's just calculate it actually. So your distance is going to be, so what's r of this number over here? And because we want the range, which is the horizontal distance, we're going to take this over here. So to 1 decimal place, that's going to be 79.5 meters. That's it. Next question. A fielder more than 40 meters from O. So in other words, imagine a fielder. So let's call this, I don't know, let's call this over here 40 meters, and he's around over here. And what he does is, so a fielder more than 40 meters from O catches the ball at a height of 2 meters above the ground. So imagine over here, he's over here, and he catches the ball 2 meters above the ground. So 2 meters. How far horizontally from O is the fielder when the ball is caught? Give your answers in meters. Okay, yeah, so we just want to calculate this height, this x over here. And the way to do it is, because we know that the vertical distance is 2, shouldn't we just go on the r of t? So example, if we know r of t, so the here, which is over here, let's write that down. So just to pull it out, I'm just going to write r of t on my calculator. It's 15 ti plus 15 root 3 minus 49 t squared over 10 j. So we have that, and what we want, because we already know that the vertical velocity, so the vertical distance is 2, we can just take this over here, the vertical component, over 10 should equal to 2. And let's calculate that. We'll calculate the time. This over here equals 2 comma t, and we get 2 values, of course, 2 t equals that, so it should be the 5.2 for this over here, and we just need to sub r of, let's check both of them actually. If you check this one over here, r of this, control enter, what do we see? Well, the distance is not more than 40 because it tells us that he's gone more than 40 minutes horizontally, so it's not this one, so it can only be r of this one over here. Control enter. Aha, there we go. This is your answer. It's greater than 40, so that's good. So let's write t equals, so not what was t when we calculate those, 5.22, hence your distance is just to 1 decimal place, that's going to be 78.4 meters. Nice. Question 5. Let's do this. A 5 kilogram mass is initially held at rest. So acceleration 0, meaning that the net force is 0 on a smooth plane, meaning that there's no friction, that is inclined at 30 degrees to the horizontal. The mass is connected by a light inexorable string passing over a smooth plane to a 3 kilogram mass, which in turn connected to a 2 kilogram mass. The 5 kilogram mass is released from rest, okay, and is allowed to accelerate up the plane. Take the acceleration to be positive in the direction indicated. Write down a equation of motion in the direction of motion for each mass. Not too bad. Okay. So if I take this 5, let's write 1 for 5 first. If I break it down, this is 5g, and this is going this way, so it would be 5g sine theta, because it's accelerating in this way direction. So what do we know? For the 5 kilograms, so let's write it. 5 kilogram is just going to be, because we're taking positive acceleration upwards, so we're going to take the up as direction. So T1 minus, so that's your force net, minus 5g sine theta, which in this case is 30 degrees, is just equal to your mass times the acceleration. So what's your mass? It's 5 times the acceleration, which is a. For the 3 kilogram one, let's think about it. So what do we have? Well, we have over here a tension T1, tension down also, T2, and we also have its mass going down too. So because it's going down, we're taking down as positive, so it's going to be T2 plus 3g, it's 3g, minus T1 should equal 3a. For the 2 kilogram one, it's just going to be, again, this tension and its mass, which is 2g. So it's going to be 2g, because we're taking downwards as positive, minus 2t is equal to 2a. We've written, yeah, that's it, the equations of motion. Show that, so let's look at this one. So it says, show that the acceleration of a 5 kilogram mass is g over 4. So we just need to calculate the acceleration, because all of them have the same acceleration. The way that I would do this, okay, is if I add, let's say this is 1, this is 2, this is 3. If I add equations 2 plus 3, what happens? Let's think about it. If I add them, these both cancel out, the T2s. That's good. These both add up, so it'll be 5g. So let's write that down. So 5g, T2s cancel out. We'll be left with minus T1 here, equals, again, these accelerations will add up, so it'll be 5a. We have that. And equation 1, let's write that down too, is just T1 minus 5g sine 30 degrees, 5a. And, okay, if I add them, think about it, if I add them, the T1s actually cancel out, meaning that, so what's 1 plus, pretty much 2 plus 3, it's just going to give me 5g minus 5g sine 30 degrees equals 10a. And yeah, so a is what? Well, think about it. So 5g minus 5g sine 30, so which is half actually. So we can write this just divided by 2. It's 10a times everything by 2, so 10g minus 5g 20a, which in this case is 5g over 20. So a, hence g is just g over 4a. Pretty much that's it. That's how I would have done this question. So that's good. So we've shown that it's that. So let's put that over there. Hope you understand that one. Find the tension T1 and T2 in the string in terms of g. Easy. We've already calculated the acceleration. And we already know equations. For example, look at this one over here. If I rearrange this, so 5g minus 5a, so tension 1 is just 5g minus 5a. Isn't it? So, yep, 5g minus 5a. And we know already a is what? A is g over 4. It gives us 5g minus 5 over 4, pretty much g. So it's just, in other words, what's 5 minus 5 over 4? 50, pretty much, 4 times 5, which is 20. 20 minus 5, which is 15, 15 over 4. So T1, it's 15 g over 4. That's for this one. And for T2, what do we know? We know that there's already an equation for T2. This one over here. So T2 is just 2g minus 2a. 2g minus 2a. Hence, 2g minus 2, what's our a? G over 4. So we're saying 2g minus g over 2. So what's 2 minus half, which is 3 over 2g. And that's it. Pretty much, yeah. 3 over 2g, and this one over here looks also good. Yeah, those are your answers. These are your two tensions. So that's T2. So find the momentum of the 5 kilogram mass in kilogram meters per second after it has been moved 2 meters up the plane, giving an answer. Okay, we know momentum is just mass times velocity. And we want to find the momentum of the 5 kilogram if it's moved 2 meters up. So imagine going here and saying that, running this whole thing over here and saying that it starts over here and it moves over here. And this is 2 meters. What do we know? Well, we know that it started at u equals 0. We know that by using your suva, u equals 0. We know that its initial velocity is 0. We also know the acceleration is just g over 4. What else do we know? We also know that s, the displacement, is just 2 meters. And we want to calculate the velocity, your final velocity. So having all these in mind, we can actually calculate the velocity. Your velocity is what we want to know. U is 0, s is 2, acceleration is g over 4. What formula are you using your suva? So if I'm not mistaken, we have vu, so we're going to use maybe v equals v squared, actually, equals u squared plus 2a. Is that right? Okay, that's great. And we want to calculate v. So v is just the square root of u0, so 2 g over 4 and 2, which velocity is just the square root of g. Okay, so this whole film is just p, what's the mass? 5 kilograms times square root of g. Hence, your momentum is 5 root g meters, kilogram per meters, so kilograms meters per second. That's that. A resistance force R acts parallel to the inclined plane and is added to the hold the system in equilibrium. So again, equilibrium means that the net force is 0 and acceleration is 0. As shown in the diagram, find the magnitude of R in terms of G. Okay, so not too bad. So we have, let's break this down. If I break this down, so we know we have 5G, this here would go 5G sine theta, sine 30 degrees. Okay, so let's still take going this way as positive. Okay, what forces do we have? We have first for the 5G, for the 5 kilogram mass, writing our equations of motions, what are they? Well, think about it. So we have T1 minus 5G sine 30 degrees, minus R should equal 0, remember? Because it's mass times and acceleration is 0, so it's 0. What about for our 4 kilogram one? So for our 3 kilogram one, same thing. So we have one goes up like this, goes up like that. Okay, for that one, we're gonna have T2 going down. We also have its gravitational, so we're also gonna have plus 3G minus T1. Should also equal 0 because acceleration is 0. Have I made any mistake here? Just want to double check. Okay, it looks good. For the 2 kilogram one, okay, we're going to have 2g going down and minus 2t equals 0. And that's it. So we have all those. And, well, look at this. This one over here, 2t is just equal to 2g. Done. If I sub that in here, we'll calculate t1. So t1 is just the addition of this. So t1 is just 5g pretty much. Hence, now we have t1. We can use it to calculate this one over here. So r is just 5g minus 5g sine 30 degrees. So hence our value is what? Let's use our calculator. So 5g minus 5g times sine 30 degrees. So 30 degrees, and we get 5g over 2. So 5g over 2. That's your force. Nice and easy. Question 6. So, it says, a bank claims that the amount it lends for housing is normally distributed with a mean of this and a standard deviation of this. A consumer organization believes that the average loan amount is higher than the bank claims. So to check this, the consumer organization examines a random of 25 loans and finds that the sample mean is, this. So it's actually greater than that 400,000. Write down the null hypothesis. So write down two hypotheses that would be used to indicate the one-sided test. Nice and easy. So your null hypothesis, we will just write, is just going to be, normal. So like 40, let me write that mighty simple. So 400,000. And your alternative hypothesis, we're saying that it's actually greater than that. 400,000. 1, 2, 3. Done. Write down an expression for the p-value for this test and evaluate it to 4 decimal places. So, okay, easy. Our p-value is just going to be the probability that x, or because we want it, is greater or equal to the greater than 412 zeros here, given that the null hypothesis is 400,000. That's it. So probability that, change that to z, is greater or equal to 412,000 minus your null hypothesis divided by your standard deviation. Well, it's for the standard deviation, it's just, we have, what's that standard? So it's 30,000 divided by the square root of the amount of people, which is 25. So just 5. All right. So, well, actually, 30,000 divided by 5? 6,000. So, okay, that's good. So divided by 6,000. So, yeah, that's an expression. Then what's your p-value? Let's calculate that using our calculator. So first, let's calculate it'll be 12,000 divided by 600, which is just 2. So if I know this 2 here, I'm just going to go probability distributions, normal CDF. And we're saying that 2 to infinity, we're using the normal distribution. Wow, nothing happened. Why is that? So 2 to infinity. And we get this over here. That's your p-value. So to 4 decimal places, that's 0.0228. Is that right? Yes. So that's your p-value. That's it. State with a reason with the bank's claim should be rejected at 5 level, level of significance. The way, okay, you just need to know this. For these kind of questions, think about it. You just need to know this case. If p is less or equal to alpha, which in this case is your level of significance, which is 0.05, then what we do is we reject the null hypothesis. So for this one, we would reject, so null hypothesis rejection. If p-value is greater than alpha, then we will accept. So these are what you just need to know. So just knowing those conditions, let's think about this. Our p-value, what is this? Can you see our p-value over here? And our level of significance is 5%, which is 0.05. We can see that our p-value is actually less than your 0.05. Yes, so p-value is less than 0.05, meaning what? We reject that null hypothesis. So we reject the null hypothesis. So what reason whether the bank claim should be rejected? So p is less than 0.05, reject the null hypothesis. At 5% level. Confidence. That's pretty much it. That's only 1 mark. What is the largest value of the sample mean that could be observed before the bank's claim was rejected at 5% level of significance? Give your answer correct to the nearest $10. So what is the value of the sample mean? So we want the sample. So what's the largest value of the sample mean that would be observed before the bank's claim was rejected at 5 level confidence interval? So we're saying what is the probability that x, we don't know what our actual sample mean is, so we call it x bar, is greater or equal, well here we said greater or equal to, our x bar, so what are we saying here? What is the largest value of the sample mean that could be observed before the bank's claim was rejected at level of significance? So, what we want is, if we want the largest value, we can just say, okay, what is the mean? So we're trying to find the mean. So we know we could just write it as z, just quicker. So z is, we want it to be greater or equal to your x bar. Our x bar is our mean. What is our mean? Minus your, we're still using the same null hypothesis, which is 400,000. Yes, divided by that 6,000. And we want it, if we want it to be, what is the largest value? So we want the largest value sampling that could be observed before the bank's claim was rejected. If we wanted it before to be rejected, we want it to be still 0.05. We want it to be at that level, at significance. So that level of significance, which is 0.05. That's what we want. So, what I would rewrite this, because I want it to be less or equal to use my calculator. So, if I was just, for example, just draw a quick sketch. If this is 0.05, we can just rewrite this as probability that z is less or equal, or actually just less. X bar minus 400,000 over 600,000 is equal to 0.95. So using my calculator, just go on menu, go on probability distribution, go to inverse normal, and we're saying 0.95. Okay. Oh, do we get it? Yes, this should equal to x, which is what we're trying to find, minus 400,000 divided by 600,000. We're going to solve, answer, comma x. And our x value is this. So to the nearest $10, it will be, so your sample mean, 409,870. So 170 to the 10th of the dollar. Yeah, that's pretty much it. Let's put that dollar sign in there. Let's see. If the average loan made by the bank is actually 415,000 and not this, okay, so we are changing our null hypothesis as originally claimed. What is the probability that a randomly selection of 25 loan has a sample mean that is at most this? So what we're saying is the probability that has a sample mean that is at most. So our sample mean is at most So less or equal to 410,000 given or null hypothesis has changed, which is now 415000. That's it. And that's what we're using. So okay, now we're writing this as Z. So less or equal to 410000 minus 415 this divided by, so we're still doing 25 lines, and I believe that the standard deviation wouldn't change anyway, if I'm not mistaken. Yeah, it wouldn't change. They're still using the same. 600,000 should be made what? So if the average line is this, what is the probability that around? Okay, yeah. And then what's that? So let's do that. So what's 410123 minus 415123, 600,000. We get this. So we take this over here. We say go to probability distributions and go inverse this, and write it over here. Press OK. Didn't work. Wow. Calculus. Sorry, probability distribution. This. Put it over here. Enter. And we get this. That's your answer. So to 3 decimal places, that's 0.202 to 3 decimal places. And there, that's it. Alright guys, I hope you enjoyed this video and learned something. Good luck and have a good day, guys. Have a great day. Bye-bye.